Hey everyone, welcome back to Transmath 2. Today we are on Unit 2, Lesson 8, and we're going to talk about the importance of equivalent fractions, especially when we're adding fractions together. Let's look at how locating 3/5 on the number line is the same as adding 1/5 3 times. We begin with the number line from 0 to 1 divided into 5 equal parts. Next, we count forward from 0 by 1/5 until 3/5 is reached. The number line shows that 1/5 plus 1/5 plus 1/5 gives us 3/5. Let's look at another problem that has 3/5 as the sum. Begin by drawing a number line that shows fifths. Then start at 1/5 and count forward 2 tick marks to find the sum. So 1/5 plus 2/5 equals 3/5. We can use the number line to add 1/5 and 2/5 in the way that we would use a number line to add whole numbers because fractions name fifths. We say that the fractions 1/5 and 3/5 have a common denominator of 5. They have the same bottom number of 5. That's why we can add them together. If the denominators of the fractions being added are the same, add the fractions by adding the numerators and using the same denominator. For example, 3/6 plus 1/6 gives us 4/6. How do we add fractions with different denominators? What do we do when we want to add two fractions with a different denominator, like 1/6 and 1/2? Here's one way to think about it. Imagine after a party, 1/6 of the cake with black icing is left and 1/2 of the cake with orange icing is left. If the two sections of the cake are put together, how much cake do we have? From the picture, it looks like there's less than a whole cake, but more than half. We know how to add fractions with the same denominator, but not how to add fractions with different denominators. Can we rewrite these fractions so that they have the same denominator? Let's use these rods to help us first. We'll show 1/2 and 1/6. Look at the fractions 1/2 and 1/6. Notice that if we multiply the denominator of 1/2 by 3, we get the same denominator as 1/6. Remember that we can get an equivalent fraction by multiplying the numerator by the same number. So multiply the numerator 1/2 by 3. So 1/2 is equivalent to 3/6. Now we have a way to describe the fraction of cake left. We can use sixth to describe parts of the two cakes that have been combined. We can also use a number line to understand the solution to the problem. 1/6 plus 3/6 gives us 4/6. So 4/6 of the cake is left. Remember, in order to add fractions, you must have the same denominator or common denominators. For the next part of our lesson, we're going to talk about how we make sense of word problems involving fraction addition. Let's look at this word problem involving fractions. Your sister Tina is drawing with chalk on the sidewalk. It's part of a game she wants to play. She colors one section of the sidewalk so that 3/4 of the section is blue and 1/8 of the section is red. What fraction did Tina color? The picture shows that we should add 3/4 and 1/8 to solve the problem, but these fractions have different denominators. Let's use the rods to help us solve the problem. We'll use the brown rod to represent the whole. How do we choose rods needed to model 3/4? In order to model 3/4, we need to find a rod that represents the unit fraction 1/4. The red rod represents 1/4 when the brown rod represents 1/2. Now we add 2 more 1/4s to the one we already have to show 3/4. Let's look at 1/8 next. The white rod represents 1/8 when the whole is the brown rod. Because eighths is smaller and a smaller fair share, we have to find how many eighths equal 3/4 so we can add the fractions. We need 6/8. So 6/8 is the fraction that is equivalent to 3/4. Now complete the problem by adding 6/8 and 1/8. The sum is 7/8. So Tina colored 7/8 of the section of a sidewalk. We can also confirm that equivalent fractions are correct by using multiplication. We write an equivalent fraction to 3/4 that has eighths as the fair shares. That's it for our lesson today, guys. Tune into Schoology to view your homework assignment.